When you look around, reality feels solid and three-dimensional. Space stretches in every direction. Objects have depth, weight, and presence. But what if this experience is an illusion? What if the three-dimensional universe we live in is actually encoded on a distant, two-dimensional surface, like a cosmic hologram? This is the radical idea behind the holographic universe hypothesis. It sounds like science fiction, yet it emerges from some of the deepest puzzles in modern physics. Could reality itself be a projection, and if so, what does that mean for our understanding of existence? The strange origins of the idea. The story begins with black holes. In the 1970s, Stephen Hawking discovered that black holes aren't entirely black. They emit faint radiation and can eventually evaporate. This led to the infamous black hole information paradox. If black holes vanish, what happens to the information about everything that fell into them? Physics says information cannot be destroyed. But if black holes erase it, then our most fundamental laws break down. To solve this puzzle, physicists considered a strange possibility. Maybe information doesn't disappear into the black hole's core. Maybe it is stored on its surface, the event horizon, encoded in tiny fluctuations like bits of data. This idea, radical at first, became the seed of something bigger. If information in a black hole can be stored on a surface, maybe the same is true for the entire universe. What a holographic universe means. Think of a hologram on a credit card. The image looks three-dimensional, but it's actually encoded on a flat surface. The depth is an illusion created by the way light scatters. The holographic principle applies this analogy to the universe itself. Everything we see in three dimensions, all galaxies, stars, and even us, might be a kind of projection, encoded on a vast cosmic surface at the edge of space. In this view, the deepest layer of reality is two-dimensional, and the three-dimensional world we inhabit is an emergent illusion. Clues from string theory. The holographic idea gained traction through string theory, which suggests that the fundamental building blocks of nature are tiny vibrating strings. In the 1990s, physicist Juan Maldacena proposed a breakthrough, a duality between two types of physics. On one side, a world with gravity in three dimensions. On the other, a world without gravity in two dimensions. The math of the two matched perfectly. This duality suggested that a higher dimensional universe with gravity could be described fully by a lower dimensional universe without it. It was a powerful mathematical confirmation of the holographic principle. Echoes in cosmology. Could our own universe be holographic? Some cosmologists think so. They suggest that the information content of the universe might scale with its surface area, not its volume. Evidence is still tentative, but subtle patterns in the cosmic microwave background, the afterglow of the Big Bang, have been studied to test holographic models. While no proof has been found, the possibility remains open. If the universe is holographic, then reality as we experience it may be like a projection on the screen of space-time, with the real information existing at the boundaries. Does it mean reality is an illusion? It's tempting to imagine that the holographic principle means we're living in a fake world, like a simulation. But that's not what physicists mean. The holographic idea doesn't deny the reality we experience. Instead, it suggests that reality has multiple descriptions, some of which are simpler than others. The three-dimensional world is real, but it may be equivalent to a two-dimensional description we don't directly see. In other words, the holographic principle doesn't erase reality. It enriches it, giving us a deeper way of understanding the link between space, time, and information. Why information is the key. At the heart of the holographic principle is the concept of information. The laws of physics increasingly suggest that information is as fundamental as matter and energy. Black holes forced us to consider that information might be preserved in unexpected ways. If the entire universe works like a black hole, then perhaps all of reality is written into the surface area of the cosmos, like a grand cosmic ledger. Some physicists even wonder if the universe itself is a kind of quantum computer, processing information through the interactions of particles and fields. If so, the holographic model may be a way of describing that hidden computation. The limits of proof for now, the holographic principle remains a hypothesis. It is a compelling idea supported by elegant mathematics, but direct experimental proof is elusive. Physicists are testing the boundaries through high-energy experiments, astronomical observations, and new theories of quantum gravity. Each piece of evidence brings us closer, but we're still far from certainty. And that's part of the fascination. The holographic universe is not a solved mystery, it's an open frontier. Philosophical reflection: what would it mean for us if reality is holographic? Does it change our place in the cosmos? Some argue it would be one of the most profound discoveries in human history. It would suggest that reality is deeper than appearances, and that information itself is the true fabric of existence. Others point out that even if true, our daily lives wouldn't change. We would still see, touch, and live in a three-dimensional world. The holographic principle is less about erasing reality than about understanding its foundation. In a way, it humbles us. It reminds us that the universe is stranger than we can imagine, that even the most basic assumptions, like space itself, may be illusions of a deeper order. The human side of the mystery: why do we care about such abstract questions? Perhaps because humans are natural seekers of truth. From ancient myths to modern physics, we've always wondered about the structure of reality. The holographic principle connects that timeless curiosity with the cutting edge of science. It shows us that even in the 21st century, there are mysteries so deep that they reshape our concept of existence. The holographic universe may or may not be the ultimate truth. It may turn out to be a metaphor, a mathematical tool, or a window into something even more radical. But what it represents is undeniable: the courage of science to question everything, even the nature of space itself. So, is reality written on the edge of space? We don't yet know. But in asking the question, we glimpse the possibility that the cosmos is more intricate, more layered, and more astonishing than our senses reveal. And whether the answer comes tomorrow or centuries from now, the journey to find it is part of what makes us human.